In this video, we're going to talk about the fundamental theorem of calculus. So in the last video, you were probably wondering, where did this value come from? And where did this value come from? And even this one. Well, it actually comes from the fundamental theorem of calculus. And what the fundamental theorem of calculus says is that if you want to find the area between the curve and the x-axis, then all you do is you integrate f of x, and then you evaluate it. You plug in that top limit first, whatever that number is, b, plug in the bottom limit, a, and then you subtract them. That's all there is to it. So let's do that for this last problem. Now, when I integrate x, the rules are still the same. You add 1 to the exponent, you divide by the new exponent. But now we don't have to worry about the c, and I'll explain why in just a minute. So we're going to go from 1 to 4. So we're going to plug in 4. And then we're going to substitute in 1. 4 squared is 16. 1 squared is 1. 16 over 2 minus 1/2 is 15 over 2, which is 7.5. So that's where they got the 7.5 from. Now, let me explain why the c is not going to matter here. If we would have written x squared over 2 plus c, we still would have to evaluate from 1 to 4. Now, notice my notation here. This tells me I still have to evaluate. That's important when you write that. If we were to plug the 4 in here, we would have 4 squared over 2 plus c. And then we would subtract, and then we would plug in the 1. So we would still have 4 squared over 2, which is 16 over 2, plus c, and then minus 1/2 minus c. Look at what happens to those c's. Notice that they cancel out, and that is always going to happen. So that's why when you start doing definite integrals, you no longer need the c, because the goal is to get a number. And when we get that number, then those c's are going to always cancel out. Now, that's different than an indefinite integral. Indefinite integrals need the plus c because you're finding a family of curves. Let's look at that other one. Integrating from 1 to 4 of x squared dx. So, rule is you integrate x squared. That's x cubed over 3. Okay, if I was looking for an indefinite integral, it would look like this. That's not what I'm looking for. I'm looking for a number that represents this definite integral. So I do not need the plus c. It's just going to cancel out. So we're going to substitute in the top limit, minus substitute in the bottom. So I've got 64 over 3 minus 1/3. Now 63 over 3, which reduces to 21. So that's where that came from in that last section. And we could do the same thing with that last one going 4 to 5. When you integrate, still x cubed over 3. But we're going to evaluate from 4 to 5. So we're going to have 5 cubed over 3 minus 4 cubed over 3. 5 cubed is 125. 4 cubed is 64. And 125 minus 64 is a 61. So we have 61/3. So there's our answer. Okay, let's do just a few more. Suppose we want to integrate from -1 to 4 of 5x to the 4th minus 12 dx. Okay, integrate first. So this is 5x to the 5th over 5 minus 12x. And then we want to evaluate from negative 1 to 4. I like to reduce before I do that. 5 divided by 5 gives me just x to the 5th minus 12x, going from negative 1 to 4. So we're going to plug in our top limit. So we're going to have 4 to the 5th minus 12 times 4. Notice I've put parentheses around that. This is my f of b. And then I'm going to subtract f of a minus. And then I've got negative 1 to the 5th minus 12 times negative 1. This is my f of a. So let's simplify this. We've got 4 to the 5th so that's 1024 minus 48 minus negative 1 to the 5th is negative 1. Negative 12 times a negative 1 is a positive 12. So I have 1024 minus 48, which is 976, minus 11, which is 965. So let's do another example. Let's say we want to integrate from 2 to 8 of 1 over x plus 1 dx. Okay, this is going to be a u substitution. We're going to let u be x plus 1. So dx is 1, du is 1 dx. Notice we have everything accounted for. There's our u. This is our du. So we can do our rewrite. When we rewrite this, I'm going to have 1 over u du. Okay, now I either have to stay in the world of x's or I have to switch to the world of u's. I'm going to the world of u's because u is much easier to deal with. That means that these numbers are going to change. These numbers are in the world of x. I need to know what are they in the world of u. So let's figure out our lower bound. So we said that x was 2 in the world of x. U is going to be x plus 1. So 2 plus 1, which is 3. And then we got to do the same thing with the upper bound. We're just substituting it into our u substitution. So if x was 8, because that's what we were given in the world of x, then what's u going to be? Well, if I plug 8 in here, I'm going to get 8 plus 1, which is 9. So now I'm integrating that. So what's nice about this is I won't have to do the back substitution. I can just stay in this world of u. And that's only because this is a definite integral. So when I integrate, I'm going to get the ln of u. And we want to evaluate it from 3 to 9. So that's going to be the ln of 9 minus the ln of 3. And we can use log properties to simplify that. When you subtract, that's really a division of the arguments. And this is really going to be the ln of 3. Let's do another one with a u substitution. So I'm going to integrate from 0 to 1. I have x squared plus 1 to the 7th times x dx. So u would be the inside function x squared plus 1. Du is 2x dx. Let's think about what we have. We have u. Notice we are missing the 2 from the du. We can multiply it in as long as we compensate with a 1/2. So now when we do our rewrite, we're going to have 1/2 times the integral of u to the 7th du. But I like this world of u because that's so much easier to integrate. So we've got to change the bounds. So let's think about what the lower bound is. Okay? In the world of x, it's 0. To find u, I have to plug 0 into my u substitution. So I have 0 squared plus 1, which is 1. The upper bound, x is 1. To find the u, I substitute 1 in here. 1 squared plus 1 is 2. And this is so much easier to integrate than thinking things in terms of x. So let's integrate and evaluate. When I integrate, I'm going to get u to the 8th over 8. And I'm evaluating from 1 to 2. So I've got 1 over 16 times u to the 8th, going from 1 to 2. So I've got 1 over 16 times 2 to the 8th minus 1 over 16 times 1 to the 8th. We need to know what 2 to the 8th is. That's 256. 1 to the 8th is 1. So I'm going to have 255 over 16. The last thing in this section is finding the average value of a continuous function over an interval. And all it is we're going to evaluate that integral from a to b of f of x, but then we're going to multiply that answer by 1 over b minus a. And that's going to find the average. So when you think about average, to find average, you kind of think about the mean, right? So you add up all the numbers and then you divide by how many you have. This is kind of the same thing. When we talk about f of x from a to b, integrating f of x from a to b gives us that exact area under the curve. And then when I multiply that by 1 over b minus a, I'm multiplying by the reciprocal of the width of that interval. So it's kind of like you're dividing that by the width of the interval, which is similar to what we do in statistics when we find the average of something. We divide by how many numbers we had. Here we're dividing by how many numbers or what the width is. So let's look at an example. Let's say we want to find the average value of the function g of x is equal to 4x squared minus 3x. And we're going to go from negative 2 to 2. So average value is 1 over b minus a times the integral of a to b of f of x dx. So we're going to just substitute in what we know. It's 1 over 2 minus negative 2, integrating from negative 2 to 2 of f of x dx. So we just have to evaluate this. So this is going to be 1 over 4. And we're going to have 4x cubed over 3 minus 3x squared over 2. And we want to evaluate that from negative 2 to 2. So we have 4 thirds times 2 cubed minus 3 halves times 2 squared. And then we're going to plug in the negative 2. So we're going to have 4 thirds times negative 2 cubed minus 3/2 times negative 2 squared. So I want you to notice my parentheses here. This is your f of b. This is f of a. All of that is multiplied by the 1/4. So we have to work inside out. You have to be careful with your parentheses here. So we have 4/3 times 8 minus 3/2 times 4 minus 4/3 times negative 8 minus 3/2 times positive 4. Once again, notice my parentheses. I'm evaluating f of b here, f of a here. So I've got 32 over 3 minus 12 over 2 minus negative 32 over 3 minus 12 over 2. So I have 32 over 3 minus 12 over 2 plus 32 over 3 plus 12 over 2. So now I've distributed that negative to everything in there. And we end up with 64 over 3 plus 0 because those 12 halves cancel. So I have 1/4 times 64 over 3. But 4 and that 64 reduce. So this is going to give me a 16 over 3. So there's my average value of the function over that interval.